Hi, a viewer called Burt asked for the people to have a look at this EV charging point. I get some weird and wonderful things on this channel, don't I? And he even sent me these, which are a pair of wire cutters, or wire strippers rather. So thanks for that, Burt. So the story with this was, it used to belong to one of his friends and it was replaced under warranty because this one just stopped working. So he's got an EV and he thought it might be useful as a spare for his EV. So let's see how it comes apart and let's see if it can repair it. And let's hope it doesn't live up to its name, Zappi, because I don't fancy getting a zap of it. So let's see how it comes apart. Well, I've got a couple of catches here. And I think this part then comes off and that reveals some screws around the edge here. So I'll just grab a screwdriver. Let's start by removing those. Let's see if this top one's to come off now. I'm still caught by this screw here. Right, let's see what we've got in here then. Right, well, it might be easier if I just disconnect this ribbon cable for now and then we'll just have a quick look over, see what's inside of this. Let's start with this board first. That looks like an ESP32 there. And just see expressive just here. I'm not sure what this device is, but again it looks like some kind of either Bluetooth or something maybe. So I guess they're using this for some kind of Wi-Fi control or something. Then again, the ESP32's got Bluetooth built in as well. So unless this is an ESP8266, but it looks like it's got too many pins. I think it's more like an ESP32. Looks like we've got an Ethernet port there. And that looks like a serial EEPROM possibly. Let's see if there's anything else underneath this little board here. Let's just pop that out. I'll try to. Oh, we've got another chip under there. Let's zoom down on that. Looks like some kind of Texas Instruments. Yeah, TM4K-AF and one of those real-time clock oscillators. And there's another oscillator there. I've just replaced one of those in I think it was a time-lapse camera that had failed. Quite unusual for those to fail as well. Right, let's just zoom back out then. And I'll pop this board back in. And then we'll move on to the bottom board. So I've got a couple of big relays here. It's like 3. And looks like we've got a couple of transformers down here. And looks like a couple of more microcontrollers and another little sub board down there. Let's just see if we can see anything on those. Some kind of Atmel chip there. Actually they're both Atmel chips. So by the look of this, especially with it having a resistor network there, I guess these are being used for measuring voltage and current on the mains. That's what I would think therefore. Because we have got a couple of current transformers here that go onto the cables that go onto the plug that plugs into the EV. So I think this is more like just like a big fancy electric meter from what I understand, but I could be wrong. Let's See, I'm not too familiar with EVs, I don't have one myself, so I've got a few test points here anyway. Well, we've got some voltage test points here. We've got a 3.3, 5, minus 12, plus 12 and a 24. So I think I'll connect the power up, we'll plug the display back in, and then we'll have a poke around on some of these test points and see what voltages we've got. Right, I'll just go and grab a power lead. Right, I've got a power lead hooked up. It's just a IEC lead that's chopped up with a 5 amp fuse in. So I'm just going to plug this in. So this is it live now. Let's just see if we get anything on the display. And that would be a no. Right, let's get the test meter and we'll check for some voltages. Let's see if I can put those current transformers to one side for now. Let's just check that we're getting power into it. So let's go on volts AC. And yes, we've got 243 coming in. So let's just see what we've got on the output. I'll just try and zoom down a little bit more. And I think I'll use this voltage regulator as a ground. Right, so this pin here has marked 3.3 volts. And we don't have anything. This one's 5 volts and we have nothing. This one's minus 12, which it doesn't appear to have anything on either. Plus 12. And this one's 24. So none of them have got anything on. I wonder if there's a fuse or something in here. Right, so the problem seems to be on the power supply. So I think what I'll do, I'll disconnect it from the power. We'll take this board out. I'll just disconnect it from the display again and then we'll just have a look over it. Actually, I'm just going to unplug it a sec. I'll just disconnect it from the display just in case there's a short on the display or something. And that could be causing the issue. Right, let's plug it back in. Let's check we've still got mains. Let's just try that again. Right, so we've got nothing. It's like there's no mains going there. Right, so I'll switch this off. Right, I'll get the meter out of the way and then I'll take this board out. Right, I'll get this big lump of plastic out of the way as well, I think. Just to make it a little bit more easier to work on. Right, let's just flip the board over and let's have a look. So it looks like we've got a transformer here. So I guess that'll be the primary winding there. And it looks like we've got another, I don't know if that's a transformer or a power supply. Let's just zoom down a bit on that. So that looks like a little DC to DC power supply there. 100 to 240 input and 24 volt output. So that must be the power input there. Right. Let's just zoom back out a little bit and I'm going to plug this in and we'll just see if we get 240 on those points and on the transformer. Right, so I'm going to plug this in now. And very carefully, I'm just going to go on volts AC. Well, we're getting power into that. We're getting power into the transformer here. Yes. And we're getting anything on the output of the transformer. Yes. And yes. We're getting anything on this DC supply. And that'll be a no. Right. I'm just going to unplug it now. Let's just go on resistance and we'll just see what we get across this DC supply here. Because either the DC supply's failed or there's a short. So let's have a look. Oh, we're about 2.8 ohms there, so that seems rather low. So has this power supply failed and shorted inside, or is there a short somewhere else? Let's just have a look. Let's just see where this power supply goes next. Well, it looks like we've got a little power supply here. So I guess that takes the 24 volt input and drops it down to 12 volts. The minus 12 I guess might come from here, but we didn't seem to have any minus 12 either. Let's just check the resistance across these caps. Let's try and get the meter in shot at the same time. Let's go on this cap here. We've got 2.9 ohms again. Let's try this one. 2.9. So I think what I might do, just to try and isolate the problem site, I mean, we could try some voltage injection, but if the fault's in here, it's not going to show anything because this is all potted and encased, this little power supply here. So what I might do is desolder this, and then we can check to see if we've still got a short here. Then we'll know if the problem's in the power supply or if it's something on the board. Right, we'll get the iron out. Right, so I'm just going to add a bit fresh solder to this first, just to make it easier to desolder. It might sound a bit counterintuitive, but it does help. Especially with being a leaded solder, because it melts easier than the non-leaded. Let's see how we'll get on with this then. Right, so I'm just going to try doing that again. Right, try some flux and some solder wick, see if that does anything. Right, I want to see if I can get this off. It's always the same, isn't it? Especially when you're trying to do stuff on camera. Right, after a little bit of persuasion, I managed to get the power supply off. So let's just check the output here. That seems okay. That's just the capacitors making the meter go a bit weird. So it's saying minus ohms. So that seems okay. So the short must be from here on over. So let's just check what we get on these 2 points here. Well, that's strange. Does that go to there? Yes. So is that one ground? Unless one of the tracks or something's not making proper contact now, I don't know. Let's just try across this capacitor. Right, well we've still got a short there. don't know why it's not showing on the board there now. Ah, it's because the ground is on the other side of the board, and because we haven't got the pin going through, it's not making contact. I would have thought the wire would have went all the way through there though. Right, so we've still got a short on the board. So what I can do is use the bench power supply. We'll try injecting 1 volt at an amp, and then we'll see if anything starts getting hot with the thermal camera. Because it could just be one of these capacitors has shorted out, and that's what's caused the whole thing to stop working. That's all it would take. Right, I'm going to tag a couple of wires on this and couple it up with the bench power supply. 1 moment please. Right, I've got the bench power supply set up at 1 volt and 1 amp and connected to the board. So let's get the thermal camera out. I'll just zoom out a bit, a fraction there. Right, let's switch this on and see if we get anything. Well, it's drawn 400 milliamps, but I can't see anything getting hot. Let's just try up on the voltage a bit. Let's go to 3 volts. Let's just try that. I think there's something getting hot there. Let's just find something to point with. Well, that's actually the end of my wire there. So whatever it is, it's probably shorted. Yeah, it's actually the wire getting hot there. So that hasn't really revealed anything. I'll switch this back off. So what I think the short's around here somewhere. So I'm just going to get the test meter again. We'll just go on to continuity. I'll just go on this ground point here. So we've got a short on this capacitor here. And this capacitor here. Not on that one. Not on that one. So if it was a shorted cap, I think the caps would have been lighting up. So I think it could be this IC here has gone faulty. Let's just check a little bit further along here. Let's try these caps. So those seem okay. Let's just try this voltage regulator. This should be ground. So I suspect the fault's going to be this IC. So I'll get this under the microscope. We'll see what this IC is. We'll see what the pinout is on the data sheet, and then we'll remove it and see if the short disappears. Right, so I'll set the microscope up. Right, so the chip is the D9E302. So I'm going to see if I can find a data sheet for that. I've had a look at the data sheet for the chip, and pin 2 here is the voltage input. So when we see where that comes from, it comes from the 24 volt supply, and then goes to this capacitor to ground, through to here, through this capacitor again to ground, and then into pin 2. And apparently this chip has got a big thermal pad underneath it, which is probably why my wire was getting hot before the chip was. So this might take a fair bit of heat to get off. So what I'm going to do, I'm going to put a bit of flux on it first. Then I'm going to use my ATTEN ST-862D Rework station to hopefully heat this up and get this off. So I'm just going to spin it round a little bit just to make it a little bit easier. So I'm going to bit of a better angle to get it off here with the tweezers. Something a bit like that perhaps. Nice, I'll put some flux on it. And I'm going to use probably 450 at about 3% airflow. Actually, I'm going to turn it up to 6%. Nice, let's put that capacitor back into place. Right, let's see if I've still got a short on these caps now then. Yeah. Might be the caps and I might have been wrong about the chip. Right, let's pull the caps off then. I hope it's not a problem with the board, like layers have gone or something. Let's pull both of these caps off. Actually what I might be do is just slide them along a little bit. Being a bit stubborn this one. Right, let's see. Oh, that one's not shorted. And neither's that one. Let's just try from. I've still got a short on the board somewhere. Right, I think we'll require some more investigation then. Well, I've refitted the IC on the two capacitors there. And I'm having a bit of trouble tracing where this 24 volt pin goes, because it goes here, but I've got a feeling it goes elsewhere as well. And with this being a multi-layer board and it's got screening all over it, even if you shine a torch underneath it, you can't really see a great deal. So, I just so happen to have an X-ray machine. So let's throw it in there and see what we can see. So I've just finished taking an X-ray of the board, and this is the IC and the capacitors. And this is the ground, and this is the 24 volt supply, and that's got the short on it. So let's adjust the contrast a little bit on this. So we've got a track, comes up to this diode here and feeds this IC. Now I've checked that diode and that's okay. And obviously goes up to where we're measuring the caps there. You can see where it goes to those pads there. And then to that IC. But what I have noticed, it also seems to come along here. And then disappears under this transformer. I'll just adjust the contrast a little bit so you might be able to see that a little bit better. And if I look at the wire here, you can just see it's about there. And that seems to disappear, and it's quite a thick track. And if we look, if there's any other tracks about the same sort of brightness and about the same thickness, it seems to be this one here. And then if we go down, it seems to go to this relay here. And then it also seems to shoot off over in this direction. So it seems to go to the other side of the board as well. It's not just on the side I was looking at, it seems to go over towards the high voltage side of the board. So I think we'll go and have a look at that side. Just before we do that though, I'm curious to see what's in this thing. It's just a black resin filled box. So let's shove that in the X-ray machine and we'll see what that's got in it. Right, so I managed to X-ray it. This is where the mains comes in. So I'm not sure if that's an NDC and that's a fuse or something perhaps. We've got a little bit of filtering. Looks like we've got a couple of mains caps here. And that's the main transformer inside. Possibly another inductor on the output maybe. There's a few surface mount components, and it looks like there's a capacitor on the output there. You actually see the internals of the capacitor. So yeah, I just thought we'd have a quick look at that. Might be a little bit interesting, that's all. Right, let's go back over to the mat then. Right, I've tacked some wires onto some thicker parts of the board. This is a big ground plane here, so I'm using that as the ground, and that's the thicker 24 volt track. You can actually just see it through the board there, which comes to this point here, and then it disappears off across to this relay, and it goes somewhere else as well. So what I'm going to do, I'm going to get the thermal camera out again. Switch this on, and this is the Koitz KTIW02. They've actually just brought a new model out of this camera. It's got some better features and that and stuff. So let's put the power supply on, and let's see if I can see anything heat up. I've got it set to 24 volts at 1 amp currently, so it's on there now. Now, hold on, is that something there? Certainly looks like something there. So, it looks like there's a couple of capacitors maybe behind here. Now, because I was using the thermal camera from the other end of the board, I wouldn't have been able to see that because there's big relays and other things in the way. Because you're looking at a top-down view of the board. When I'm looking at the board, I'm getting sort of this sort of view of it. So the thermal camera wouldn't have picked anything up there, because it's around the back of here. So I'm going to get this back under the microscope, and I think there might be a couple of capacitors there. Right, so I'll switch the thermal camera off and I'll get it back under the microscope. So it looks like it could be one of these two caps. So I'm going to put some flux on first. I'm probably just going to try the iron to get these off. Right, that's the two capacitors removed. Right, let's see if we've got a short across here then. And we don't. Let's see if the culprit was this capacitor. And there we go. 2.2 ohms. Let's just try the other capacitor. I'll just get that one in shot. And that one's okay. And that's the shorted one, once I get the probes on properly. Right, well that was a bit of a long-winded thing to find that. So what I'll do, I'll try and measure this cap and we'll replace it. I mean, I'll probably be fine without it, but we might as well put it back to the way it was. So I'll see if I can find out what value this cap is, and then I'll fit a new one. Right, back in a moment. So I've just finished fitting a new capacitor, and I've used the 10 microfarad one, because that one's 10 microfarad, and it's on the other side of this filter here, so I assume that one's probably going to be 10 microfarad as well. So all I've got left to do now is to put the 24 volt power supply back on, and then we'll give it a test. The power supply's been refitted. Let's just double check that way you don't have any shorts now. So I'll go on this capacitor. Or if I go from the 24 volts to ground, just because the capacitors have got some charge in them now. But there we go. Right, let's get this back in its case, connected to the display, and then we'll put some power on it. Right, got my little power lead here. Right, so all the wires back on. Let's grab the display. Right, I'll zoom out a fraction. So let's plug this in and see what it does now. It still doesn't appear to be doing anything. Right. Well, we don't have any smoke or anything. Let's see if we've got any power. Let's just check we've got mains coming in. And we do. Let's just go into volts DC, see if we've got any power here. And no. We still have no power. So what on earth's going on now? Oh, we've got minus 12 there now. We still don't have any 24 volts. We've definitely got minus 12, we didn't have that before. Right, looks like I'll have to pull this board out again then. Right, I've got the board out. Let's just go on to volts AC. I just want to check that we've got 240. Go on to this little transformer, or this little power supply here. And we do. Let's see if we're getting 24 volts out of it. And we are. Right, let's unplug that a second. So why aren't we getting 24 volts to that test pin? I've just got this unplugged at the moment, so... Right, so I'm just going to plug it back in now. Let's find a ground. Well, we've got nothing there. Now I know that track also came to here. So we've got 24 volts there. But not at this point. So I'm wondering if there's a problem with the wire or track under here, because the x-rays show that that track goes over to here as well, but obviously it isn't. So let's see. Yeah, we're definitely not getting 24 volts there, but we are to here. I can try resoldering that, but I think that might cause problems if it's kind of an intermittent connection. So what I might do is run a jumper wire from the bottom of this power supply over to this point here, and then at least we know we've got 24 volts. I think I'll do that. Let's use a bit of Canon wire or something. I've got some knocking about somewhere. Might need something slightly thicker. Right, I've run a little patch wire from the 24 volt here to the point there. see what it does now when we switch it on then. Let's see if we've got any voltages that we should have then. So, I'll go on the ground here. I've got 24 to there. 12 volts to there. Minus 12. Plus 5. 3.3. Right. I think we're getting there eventually. Right, I'll try it back in the case now then and we'll plug the screen in. Right, board's screwed back in. Let's plug the screen in again now. And fingers crossed it actually works now. I'll just zoom down a bit and let's plug it in now and see if it all lights up. Fingers crossed. Oh, init upgrade. Well, I think that's it. And I haven't got a clue what you do with it, so I've just switched it off and on again, and I was greeted with this nice little animation thing here with a little EV and that, saying EV disconnected. But this is as far as I can really test this because I don't have an EV to plug it into. But isn't it crazy to think that this whole unit was rendered inoperable by that? One tiny little component and this whole thing rendered useless. Bit crazy when you think about it, isn't it? So just a little bonus bit here. I was just having a look at the charge log and it doesn't actually look like it's had a lot of use, this. It's less than a year old. Just thought you might find that interesting. It's only charged 3,500 kilowatt hours or so. Right then, I think we'll call this one a fix then. So if you enjoy this video, give it a thumbs up. If you want to see more like it, please subscribe. Any comments or questions, leave it in the comment section below. And as always, have a great day. Thanks for watching.